everybody. So yeah, I'm Nick Matthews. I'm a Principal Solutions Architect with AWS, and today we're going to dive into what's new on AWS networking features. We've been pretty busy over the last year. We released a bunch of new features at reInvent. Congratulations if you were there. It was a great show. So we're going to cover sort of like the last 6 to 9 months or so of what we've been doing in the networking world. So for starters, let's go over the Amazon Virtual Private Cloud, or VPC. So a virtual private cloud is, we say it closely resembles your on-premises data center. So what does that mean? It means it's your network segmentation tool inside of AWS. If you put 2 virtual private clouds inside of your AWS account, resources in those 2 different VPCs will not be able to talk to each other unless you create some sort of networking configuration between them. So every time you create a new account, you'll put things in your own VPC. We have default VPCs, so every account since 2013 or so has its own VPCs, and it allows you to create your own applications, your own subnets, those kinds of things. So subnets live in availability zones, or AZs, and you have the ability to create your own custom networks inside AWS, flexibly and on demand. For those that are maybe more familiar with on-premises networking, this might be a very common sort of architecture you would have. So you maybe would have 2 data centers that would have maybe some VPN coming in, a wide area network, maybe something like MPLS. Your data centers may be connected with something like some dark fiber, so you can do synchronous replication or something similar. And then you can put your applications in your data centers and connect to them through a variety of different ways. If we look at this in AWS world, it looks pretty similar. So your VPCs are sort of your virtual data center. You can have VPNs coming in either side. If you want to connect into your on-premises network through some sort of wide area network or private circuit, we have a service called AWS Direct Connect, which allows you to do that. If you want 2 VPCs to be able to directly talk to each other, we have a feature called VPC Peering, which allows you to do that. So that's sort of like the VPC in a nutshell, in a few minutes for those of you that may be slightly new to networking. For the rest of the talk here, we'll be talking about the new features. So let's get into it a little bit. So this is an exciting feature that we launched at reInvent called Inter-Region Peering. So if you're familiar with VPC peering and sort of what I just described, it's actually pretty simple. So we've got 18 regions across the world, on 4 or 5 continents now, and you can create VPCs in each of those. You may have different accounts, and so VPC peering allows you to securely and privately access VPCs across accounts. So before, you may have to do VPN, or you would have to go over the internet. So if you've configured a VPC peer today or any point previously, this looks the same, except for now there's an additional option of, would you like to connect to a VPC in a different region? So one of the nice things here that the AWS handles for you is the security. So in traditional networks, whenever you cross boundaries such as the ocean or the internet in general, any place where you've got untrusted circuits, encryption is important. So as part of this feature, all of the traffic you send over inter-region peering is encrypted by AWS. So we use a set of encryption keys on a per region basis that encrypts all the traffic between those 2 regions with a set of keys to make sure that your traffic isn't decipherable from other people's traffic, which is good from a security perspective. This is great from an ease of use perspective because it's very simple. You don't have to do any sort of VPN configuration. You don't have to do any complex routing configurations. It looks just like VPC peering, except for you can do it in different regions. So what does this change about your designs and how you go forward? Well, previously, you would either have to go over the internet, hopefully over secure protocols like SSL, or you would have to create sort of more complicated VPN configuration. And if you create a VPN configuration, it could have been a bit of sort of heavy lifting to do that. So today, if you want to use this for things like data replication, you want to use this for maybe disaster recovery, those types of use cases where you got 2 VPCs that need to share data with each other, this is a great way to do that without introducing additional complexity. We don't have it everywhere quite yet. We have got some limitations in terms of the backbone and where it reaches and how this encryption works. So right now, it's not available in China or in the Korea region in Asia. As well, the security groups that are available between VPCs in the same region, they're not available yet. That feature doesn't exist. So let's talk about security group rule descriptions. If you have your VPC, you've got maybe one VPC here with a 10.1 CIDR range. You've got some AWS applications and services running. To secure each instance, you put a security group around the instance. If you take a look at the security group configuration, that's your security group. And what's that made up of? Well, it's made up of a set of rules. If we take a look at those rules, there's a bunch of TCP and IP information, which can be hard for a lot of people to decipher in terms of what is this port there, why is it there, who put it there. It has a lot of open questions. So what we added late last year was the ability to add descriptions to these rules. So this allows you to do things like, from a compliance perspective, say like why did we open this port up? You know, who put this here potentially? Or you could even add timings, because you can add up to 255 words of description in here. So this makes it very easy to sort of figure out why we put this rule in here, when, how, and you can add some context to these important security group rules, because 2 years from now, you may not know why you added security group. So this is best practice, and it's very easy to do. So how does this change your designs? Well, before it could be sort of hard to understand how to use these things. And now it makes it much easier again, from a compliance and history perspective, and hey, what would break if I remove the security group sort of decisions. Those are much easier to make. So let's talk about expanding your existing VPC CIDR range. So if we take our same sort of application here, we've got an existing CIDR range of that 10.1/16. We have a set of subnets in here. And this is good that we have a /16, we have a lot of space to expand, but maybe a couple things could happen. Either we run out of addresses in that /16, maybe we didn't use a /16, maybe someone gave us a /22, which gives us a very limited amount of subnets. And either we want to re-IP address our instances, or we run out of room and we want to add more space. So what we can do now, as of late last year as well, we can resize our VPC and add additional CIDR ranges. So in this case, we're going to add 10.2/16. This allows us now, when we create, maybe if we want to add an additional availability zone, we can create subnets in that availability zone that use this new CIDR range. So, maybe we'll create a 10.2.1 and a 10.2.2. So any of the new subnets that we use can use the new CIDR range. In this case, the 10.1 subnets would not be able to use the 10.2 CIDR range, but new subnets that are created would be able to use the existing CIDR ranges. So if we take a look at how to do this, you would add the 10.2 CIDR range and be able to use that on new subnets. Inside the console, what this looks like is we're looking at our VPCs. Here you can see that our existing VPC is 10.1/16. If we wanted to add one here, what we can do is go to the actions, click that, and we're going to have this new option here to edit the CIDRs. So in that edit CIDRs window, you'll see the 10.1/16 is associated. We will click add, and then that will give us a text box. We'll add our 10.2/16, press accept, and it's going to sort of cook on that for a second. And then it's associated. Then when we go back and look at our VPC CIDR ranges, we'll see that the 10.2/16 is there. So this is great because, especially for smaller VPCs, it was pretty easy to run out of space, especially if your workloads were successful or migration was successful and you wanted to add more things to your VPC. Or if you wanted to change your addresses, you would have to delete and recreate. So this sort of changes the way you do CIDR design. Historically, we've always said, hey, go as big as you can. If you can get a /16, use a /16 because it's got room for something like 65,000 subnets. Now, especially if you're in a larger enterprise or a company that has limited IP address space, you can start smaller and then add as you need. So that's very convenient from a design perspective. So you can add up to additional 5 CIDR ranges here. One of the little gotchas on this one is we have some specific ranges you're allowed to add depending upon your original CIDR range. One of those reasons is whenever you choose your original CIDR range, other services like maybe workspaces, they actually choose some CIDR ranges in the background so that you can interoperate with those services sort of transparently. Now that we've added this feature, that transparency is a little bit different. So for instance, if you start with a 10.0 or 10. anything, you have to stay within the 10 space. Same thing if you use the 172.16 space or the 192.68 space. So if you're within one of the RC 1918 spaces, you have to stay within those boundaries to add addresses. They don't need to be contiguous, so you can add 10.1 and 10.100. Alternatively, if you're using public address spaces, you have to stay within the public address spaces. But other than that, you sort of have, if you're in the 10 space, you have access to the whole 10/8 range of addresses. Let's talk a little bit about Direct Connect and Direct Connect Gateway. So for those that may not be familiar with Direct Connect, this is sort of what a basic topology looks like. On the left, we've got on-premises, some sort of data center. In the center, we've got the Direct Connect point of presence. So we've got something around 75 of those today. We have an AWS router at that location. You would find a way to get to that router. So when you order a Direct Connect port on the console, we would basically assign a router and port for you. We would give you what's called an LOA CFA, which is essentially some paperwork that allows this Direct Connect location to bring a pair of fiber into that router. So that customer router is connected to our router. There's some BGP there, there's some VLAN configurations. And from there, you can start associating connections to your VPCs. So in this case, you would create what's called a private virtual interface, or VIF, to each of your, in this case, 2 VPCs. Each Direct Connect port can do up to 50 virtual interfaces. So every time, once you get that port up and running between our router and your router, that's anywhere between 50 megabits per second to 10 gigabits per second, you would create a virtual interface each time you add a new VPC. So that's BGP pairing as well as a VLAN ID. If, in this case, you wanted to add redundancy, which we would recommend, what you would do is you find a second Direct Connect location, and then each from that port, once you get it up and running, you would have 2 diverse paths, maybe out of your wide area network or MPLS or dark fiber to a different location. You would have that into our router, and then for each one of these Direct Connect ports, you would create virtual interfaces to each of your VPCs. So in this case, we've got a fairly redundant setup where we've got 2 different locations, 2 different VIFs to each of our 2 different VPCs. Working pretty well. One of the things we can do here, if we wanted to increase the bandwidth, is we can do what's called link aggregation, or lag. So we can bundle up to 4 ports, and what's the protocol is actually LACP. So you can do LACP link bundle between your router and our router. That also gets you an additional 50 virtual interfaces per connection. So if these were 4 1 gigabit connections, you would have 200 virtual interfaces you can create on that 4 link aggregation port. So it's a nice way to get virtual interfaces if you need those. Otherwise, what's nice about this link bundle is if one of these links fails, there's no BGP peering failover. From a layer 2 perspective, the failure is handled gracefully, which is nice. The other feature that we just released late last year as well is what's called Direct Connect Gateway. So in the previous example, every time we create a new VPC, we need to add that VPC to a virtual interface. Now, right now, Direct Connect Gateway works within the same account. So let's remember that when we're talking about this design. But if we've got 2 VPCs or more in the same account, what we can do is we can create 1 Direct Connect Gateway. From here, what we do is we create a virtual interface, just the Direct Connect Gateway. The VGW is associated to the Direct Connect Gateway. So in this scenario, we have sort of a fan out from the Direct Connect Gateway to the 2 virtual private gateways. So if you have, a bunch of VPCs in an account, you can create a Direct Connect Gateway and then attach it to your VIFs and connect to multiple VPCs from 1 virtual interface. which is nice. So essentially, if you have multiple accounts, you would create a Direct Connect gateway per account, attach the VGWs there, and sort of go forward. And even if you're only going to attach a single VGW to your virtual interface, you should probably put a Direct Connect gateway in there anyways, because the Direct Connect gateway doesn't have any additional cost. And if at some point you create a second VPC, you could just attach that to the Direct Connect gateway without modifying your existing virtual interface or causing any downtime or anything. So it's a great way to do that. As well, there's other features for Direct Connect gateway. So in the previous example, those were two VPCs in the same account in the same region. Well, let's say we want to do some disaster recovery and we want to put two VPCs in another region. All we have to do is associate the VGWs from the other VPCs into our Direct Connect gateway, and it just works. So this all uses the AWS global backbone. So we have backbones going all the way around the world, and whenever you associate the Direct Connect gateway, it allows you to ride that backbone from any of our Direct Connect points of presence to all of our regions minus China. So this is a great way to use the investment of a single port and pair of fiber to get to multiple regions globally. And from a routing perspective, the Direct Connect gateway doesn't change the availability or the data path of these packets. So it's going to use the fastest connection from your Direct Connect point of presence to the region it needs to go to on our backbone. So it stays private the entire way. As well, if you wanted to access our public services, so let's say you have a port in Virginia, but you want to access S3 in California, you can access the S3 global services over the same Direct Connect gateway as well, even though it's not pictured here. So what does this change about designs? It changes a couple things. So before, Direct Connect only allows you to connect from a single point of presence. So if you wanted to be in California and Virginia, you would have to get a Direct Connect port in each one of those locations, and then you would have to find out how to get from your on-premises data center to both California and Virginia. That could be complicated and sort of costly depending upon your global reach. As well, if you had multiple VPCs in the same account, you would have to create a virtual private interface for every single one of those VPCs, which could be time-consuming, and maybe the network team doesn't keep up with changes as fast as the cloud team. You could cause some sort of impedance mismatch there. So now with Direct Connect Gateway, you can reach public and private resources across the world without having to go and procure additional network supports. As well, you can reach multiple VPCs from the same port, which makes it easier to scale out and sort of fan those virtual interfaces out. So this is pretty cool. This is pretty nice. I have a lot of customers that are very interested in this, and they're starting to use it and starting to understand how powerful it is to get a handful of Direct Connect ports and have global reach, which makes it easier to go global in minutes, as we like to say, because 18 regions is a pretty nice number to be able to reach sort of instantly with a single Direct Connect port. All right, let's talk about network load balancer. We have a new load balancer. Let's get into some of the details here. So for those who've been with AWS for a while, you may have heard Elastic Load Balancing, or ELB. It's a pretty core component of our networking architectures and our auto scaling and a lot of what we do. And at this point, we've got 3 different load balancers. On the left here, we've got Application Load Balancer, or commonly referred to as ALB. That is, that's your layer 7 HTTP, HTTPS load balancer. So if you want to do things like path-based routing, SSL offload, host-based routing, WebSockets, and some of the sort of more complicated or any sort of HTTP-related feature, Application Load Balancer is the preferred load balancer for those types of workloads. However, we have customers that run non-HTTP workloads, some TCP-based workloads, or that performance and scaling are more important. So if customers are deploying SSL offload on their hosts, and the load balancer is just passing, for instance, layer 4, TCP port 443, or just basically TCP-based load balancing. They wanted sort of a simpler load balancer. And the load balancer, sort of previously known as ELB, is now called Classic Load Balancer. So effectively, that means that the real differentiation for that load balancer is that it works in EC2 Classic. So from this point forward, from a design perspective, you really should be choosing either application load balancer or network load balancer for your workloads. So since this is a network sort of talk, we'll talk about networking the network load balancer. So it's a network load balancer. It's a TCP-based load balancer. It's high performance. So we did some tests for reInvent where we started off at 100,000 transactions per second, cold start off the load balancer. We scaled that up to about 30 gigabits per second over a couple hours. And the only hiccups we ran into is we ran out of backend instances to send that traffic to. So the load balancer kept up fine. So every time you turn on a network load balancer, you get 5 gigabits per second of network bandwidth available. And so one of the other nice features it has is static IP support. So the network load balancer will have a single IP address per availability zone that you deploy it in. So if you're used to something like a virtual IP address and you want sort of a static address that you can whitelist through firewalls, or you need to know that IP address, this is a great load balancer for that use case. As well, it supports long-lived TCP connections. So you can send the same TCP connection to this for literally years, and it's going to maintain that session state and continue to send it to the same destination for the duration of that TCP session. One of the other nice things here is from a performance perspective, it's got extremely low latency, so we're in the microseconds of latencies here, as well as the source IP. So we do a little bit of networking magic behind the hood so that when your web server or your TCP server, or whatever it might be, receives the packet from the internet, it sees the true source IP. In both the classic load balancer and application load balancer, you would see the IP address of the CLB or ALB, which means you would have to use HTTP fields like the X-forwarded for and other ways of getting that packet. So in this case, you see the true source IP address, which is helpful for some sorts of workloads. It's API sort of equivalent to the ALB, and there's some, the same sort of deletion protection as well. So if you want to migrate to the network load balancer, we've created some scripts out here on our GitHub. So it makes it pretty easy to do this. Why would you want to do this if you're using the classic load balancer? Well, cost is a good reason. So the hourly costs are 10% cheaper, and the data transfer costs, because of the some of the performance things that we talked about, are about 25% cheaper. If you're curious on how we do that, there's some great information at reInvent on Hyperplane, which is a platform that we're using to power the network load balancer if you're into sort of like the engineering details. So, highly recommend for you guys to go out and try the new load balancer. So while we're talking about that load balancer, let's talk about PrivateLink. So PrivateLink is built on the network load balancer, so it's a good segue here. So one of the architectures I see commonly with our customers is, like a shared services VPC. So it might be logging or DevOps tools or security resources, those kinds of things that you put in one VPC, and you want many VPCs to access that. So we can do that with VPC peering. So, you create VPC peering from each of your VPCs to this sort of shared services VPC up top. There's a couple things about this that, aren't perfect. So one of the things is that when you peer to VPCs, it's mostly full VPC connectivity. We can obviously secure that further by using, more specific routing updates, or we can use security groups to make that more granular in terms of our secure policy. But it's sort of a broad stroke instrument. As well, if we have two VPCs that for whatever reason ended up with duplicate addresses or overlapping addresses, we can no longer peer those to the same place. So that creates a challenge if your development group has decided to do that sort of thing. As well, from a scale perspective, we can only go to 125 VPCs. So if you're below that, great. This thing works pretty well. If you're trying to give 3 VPCs per each one of your developers or something like that, and you're looking at hundreds of VPCs, then this may be a part of a challenge. So we have this feature called PrivateLink. So in this case, let's say we've got some sort of API that we're hosting in the shared VPC up top. All we do is we put a network load balancer in front of it. We'll get that single IP address per availability zone that I mentioned earlier. And now we can sort of, through the magic of our network magic, we can extend those IP addresses into sort of a consumer VPC or a customer VPC or a spoke VPC, whatever you may want to call it. And that IP address is going to be a local IP address. So up top, we're using 172. on the bottom, we're using 10.1. And from a security perspective, this is really nice too, because the access is unidirectional. So if someone gets a hold of this API server, they can't reach out to my consumers. So that's really nice, because now all my consumer VPCs can only access that API. It's a little bit more of a sort of a service-oriented architecture, which is great for things like microservices, APIs, any sort of client-server relationship. As well, if I pick on the developers a little bit, if they chose another VPC with the same CIDR range, this works. We can do the overlapping address ranges between two VPCs with the same CIDR range, because on the back end, we're doing some network magic, network address translation and those kinds of things, so that the spoke VPCs can reach our shared VPC here. It also scales up to thousands. It's super scalable, because this is actually what we're using for our own endpoints, which I'll get into here in a little bit. All right, so let's take a look at some of the use cases for PrivateLink. So here, we've got the on-premises data center at the bottom. We're coming in over Direct Connect into a VPC where our applications are hosted. In that same account, we've got some short shared services, and we've basically used VPC peering between these two VPCs. In the shared security services, we may have, like I said, security, logging, monitoring, those kinds of things. These applications inside the VPC are probably also wanting to go reach out to a variety of our services. In this case, I've just chosen the Amazon EC2 API, but it could be a number of any other services, things like Redshift or SSM, KMS, or key management servers, those types of services. So in order to get to those APIs, you have to put an internet gateway on that VPC. Even though those APIs are living within Amazon, you still need to put an internet gateway on there, because those APIs live on public addresses. So you go over the internet, in theory, to access our resources. It all stays within our network, because it stays inside the AWS networking, but it doesn't mean that you don't have to go over an internet gateway. As well, there may be other partner services that you're accessing from that VPC. There may be sort of software as a service offerings. There could be different sort of third-party APIs, and a good portion of the software as a service solutions run on AWS, and so it's actually running potentially in the same region where you're actually at. So, how does this change if we're over PrivateLink? As well as you may also be accessing the service through a firewall into those partner services from on-premises. So PrivateLink has a use case to work with all of these. So if we sort of redo this with PrivateLink, what does it look like? So we start with the same start, where we've got the data center, Direct Connect, and a VPC. We've got a shared services VPC. In this case, we're going to put a network load balancer in front of that service, extend that over PrivateLink into the application VPC over here. Whenever we create a PrivateLink, it's going to show up as a network interface. So from the perspective of this VPC, it looks like that shared services lives in that VPC because it has a network interface. So just like RDS looks like it lives in your VPC, the same thing would happen here. As well, if you wanted to access the AWS services that support PrivateLink, so the load balancing API, key management service, the EC2 API, we've got a growing list of those services. Same thing. You would create the PrivateLink, and it would show up as a network interface here. And since we're using this service internally for our own services, we made it possible for you to create your own PrivateLinks. As part of that, some of the software as a service partners or marketplace folks, we've got a growing sort of ecosystem of folks there that would be able to do this same thing. And so you can go and consume a PrivateLink from some of these third-party services. And what's sort of neat about this is maybe you don't have a VPC in AWS, but you're still interested in accessing those third-party services over PrivateLink. So whether you want to access our services or partner services, you could create an endpoint VPC, is what I've called it here, where you could come in over Direct Connect, access those network interfaces, and go directly to these APIs. One of the neat things is if you decide to consume these third-party services through Marketplace, so we've got Marketplace sellers such as Aqua Security, they do container security, or Cisco Stealthwatch Cloud, which does sort of network monitoring, CA for application monitoring. If you want to access any of these software as a services from your VPCs, when you provision them through Marketplace, the private link is created automatically. So you don't have to worry about any configuration. You just click on, hey, I want a private link, and it shows up in your VPC. So that's a pretty cool integration for Marketplace. If you want to add an AWS service into your VPC, this is what it looks like. So you'd go into the VPC window and say, create an endpoint. This window would pop up. You can see we've got a collection of services here between DynamoDB, EC2, load balancing, Kinesis, etc. You also see this is the same place where you would do an S3 endpoint. So we've got both gateway and interface types endpoints. So the private link endpoints that I just talked about are interface-based. The endpoints we had previously, the DynamoDB and S3 endpoint, they work differently. They use a routing table, and they work a little bit differently than the interface endpoints. So you can see that here by, it's got the word interface next to all these services. And so we've got a number of services that are releasing. So KMS, the key management system, released after reInvent, and we're hoping to have a lot more services this year that are also available here. So in terms of use cases, it's there's a couple different ones to think about. One is internal services, such as any sort of logging, monitoring, TCP-based workloads that you're sharing across multiple VPCs. Really ideal for this sort of service. As well, if you've got a network load balancer in front of anything that's useful to multiple VPCs, that's sort of a no-brainer. It only takes a few minutes to go in to the endpoint services, create an endpoint service, and then consume that endpoint services from multiple endpoints and VPCs. So if you've got a network load balancer in front of a service, it takes, I did this in my account in, I think, 4 minutes. It was super fast. Then, especially, I talked a little bit about microservices and sort of this service-oriented architecture, but since a lot of these sort of microservices use service discovery, TCP-based connection between client server, this makes it very easy to split those workloads out into multiple VPCs so that you can access them, and you can split VPCs out easier without having to worry about things like VPC peering and some of the scaling limits. As well, if you have software as a service or marketplace offerings, or if you are a SaaS yourself, this is a pretty compelling offer and way to create private connectivity to multiple VPCs and your customers as well, even over Direct Connect for private access. So those are the features we've got for today. I hope you guys found this useful, and thanks for joining.